Thank you very much. Hope you can hear me over the air conditioning. So my name is Brendan O'Flynn. I come from the Tyndall Institute in Ireland. This is primarily the work of Liudmila, a PhD student of mine who recently graduated and has now gone to a postdoc in industry and in clinical trials in a hospital in Ireland. But I guess the work is representative of a very multidisciplinary team of material scientists, electrochemical sensor developers, data analytics people, and people expert in clinical trials. So it's the work of Hassan, Marco, Daniela, and then myself. So as I mentioned, yeah. So as I mentioned, I come from a small country in the west of Europe called Ireland, and we're based in very far south of Ireland in the city of Cork. We're a research institute. We're part of the university there. So we graduate PhD students and master students, but all our work is based on research programs and collaborative research projects with our Science Foundation Ireland or with collaborators across the world with NSF or through Horizon Europe projects. Tyndall is currently about 650 researchers. We've got a significant infrastructure, but we started off in that very small building, or this is where we are currently, just here. You can't see it, the pointer, but it was built in the 1800s, and it's a very, very old building, and it's listed, so it's very difficult to change. And as a result, just recently, our funding agencies have given us a significant sum of money, many millions of euro, to double in size and give us an extra 17,000 square meters of state-of-the-art lab facilities. And we're looking at the whole area of from atoms to systems research and photonics, looking at microsystems, micro nanotechnologies, modeling of devices and theory, photonics, and we have our own fab, a couple of fab facilities developing silicon on site. So I guess my own work is coming out of a group called the Wireless Sensor Networks Group. We do a lot of IoT, embedded systems, but more recently from a group perspective within Tyndall, different groups and multidisciplinary groups of the aforementioned material scientists and modeling people and data analytics people. We're all coming together in clusters of multidisciplinary groups called, and my group that I'm working in then is called the Human Centric Systems Group. And it's focused very much in the whole area of healthcare, human analytics, and development of technology for fitness and well-being and developing medical devices. So we have a long track record of inertial measurement unit monitoring for Parkinson's disease and working with clinicians to establish the impact of Parkinson's disease, for instance, and the effect of the medication on people suffering from that. So the technologies then that feed into that research stream is around flexible electronics, sustainable materials, polyimides, textile-based electronics, and then integrating technologies and ICT onto and into those sustainable materials and flexible electronic systems. We have a strong track record in antenna design, electromagnetics, the whole concept of getting data off the body into the cloud and creating information around that data based on edge processing and AI, both in the cloud and on the edge devices themselves. So for this project, the work project that Liudmila was working on was looking at sweat. So you probably saw Professor Rogers' talk on Monday and the importance of sweat, where he was developing colorimetric technology to understand sweat parameters such as lactate and glucose and cortisol and pH. And this is what we're interested in doing as well, driven by a sporting need and a collaborative research activity that we have with sports scientists who are interested in particularly glucose, cortisol, and lactate and pH to reduce injury to the sports stars. So we were working with them to develop a non-invasive health monitoring system to incorporating wearable technology, in particular type of electrochemical sensors that we're developing for that analysis. So there's a research gap there for a real-time, flexible electrochemical sensing system. So the fundamentals of electrochemistry, they require a potentiostat. So a typical 3-electrode system is working electrodes and reference electrodes. And the potentiostat then that we developed to interface to those electrochemical sensors focus primarily on cyclic voltammetry and the chronamperometry. So the platform that we described here supports those electrochemical sensors, but I guess it's designed to be multimodal in nature. So it's not just looking at the electrochemical sensors, but it also has the capability to interface to digital sensors, temperature sensors, and accelerometry to get the whole multimodal sensing capability associated with sporting analytics. So we'll talk about the solution, the hardware components, the particular laser-induced graphene sensors that we developed, and the system and validation and conclusion and future works associated with that. So potentiostats exist. We're all familiar with PalmSense, where Sensit have a wearable version of that. And there are a number of research prototypes ongoing and available in the research community around the world. But I guess the review that we did, there was nothing there that met our requirements in terms of multimodal sensing. The ability to interface with different types of electrochemical sensors, the ability to have a reconfigurable system, and the ability to incorporate different types of digital and non-digital sensors into the system was important to us. So we developed this platform. So it's a potentiostat supporting a variety of biochemical sensors. In the first instance, the Lig-based sensors that we're developing, we're also very open and interested in integrating in different types of sensors from across the research community into our system because of its reconfigurable nature that we have, and combining that then with multimodal physiological measurements to enhance healthcare and fitness assessments. So I guess these are the building blocks that we're looking at. The core of the system, I guess, is the MCU is the ESP system that we're maybe all familiar with from the MISO system demos that we saw yesterday. We have an electrochemical shield, really, which is the heart behind the electrochemical interfacing. And the AD5941 is a highly reconfigurable device that we've integrated into the system, which makes it compatible with a very wide range of biochemical sensing and electrochemical sensing parameters. So it's got a lithium-ion battery, it's rechargeable, it's got multiple communications modalities via the MCU. So we've got Wi-Fi and Bluetooth. And I guess then the thing that really made it important for us to actually develop our own system was this capability for additional sensors and multimodal sensing. And we've developed that. We're looking at different placements of it at the moment in conjunction with our sports scientist people, and we're looking at the clinical trials now to understand what is the best option in terms of placement and acquisition of sweat and without impeding the activity of the sports scientists that we're looking at. This is the system that we developed with the main hardware components. It's a very small form factor, 3.2 centimeters by 1.8 centimeters. It's not flexible in nature, but the sensors that it does interface with are flexible, and they're Lig-based sensors that I'll talk about in just a little minute. That's the ESP32 from Seed Studio, which I guess is the core functionality. The batteries, the I2C and connectorization for additional sensors. And then the reconfigurable aspect of it. We've got two of these AD5941 systems, which gives us the ability to interface multiple electrochemical sensors at any one time and monitor them simultaneously, as well as the additional functionalities in the digital sensor. And then we've got a standardized electrochemical sensor connector to interface to the different sensors that we're looking at. So in the first instance, I guess, and this is where some of the novelty is, in terms of the overall scheme of the work, is the electrochemical sensor team are developing these laser-induced graphene sensors based on Kapton-based systems, where we're burning the electrodes into the Kapton, developing laser-induced graphene flexible sensors, functionalizing them to look at the different types of parameters that we're looking at in terms of cortisol, lactate, and pH in particular. And then we have a graphical user interface. Currently, that's on a PC. We will have an Android-based system is coming out just later this month, where we're going to be able to have real-time feedback of the parameters that we're looking at from the sports people that we're analyzing in the human trials that are coming down the track to us. So just in terms of the prototype verification, so first of all, we just had to make sure that the system works functionally, and we characterize that and compared it with, say, gold standard of the PalmSense and the Autolab potentiostat system. We did chronoamperometry measurements on the Lig sensor, and we saw a very, very good correlation between our system and the gold standard lab-based systems that we're looking at in terms of the calibration curves, and with very little statistical difference between the two systems, both when looking at a standard 0.1, milliliter milliliter molar concentration, as well as looking at different concentrations of the ferricyanide that we're using to characterize and test the system. Excuse me. And again, very good correlations at different concentrations of ferricyanide also. So I guess that's the platform that we have. We're not commercializing this. We're not in it to make money. We see it as a research platform tool. At the moment, we have very good configurations looking at CA and CV curves, but the system is, as I say, really highly configurable, and we're really looking forward to exploring different types of sensors, different types of sensor interfacing, and working with other researchers in the community who are developing sensors and maybe need to use a system like this to get data up into the cloud and do the analytics of the data. So we're testing an artificial sweat at the moment. We are currently optimizing the microfluidic system to be able to wick the sweat off the surface of the skin. We're integrating pH and temperature measurements using the additional sensor interfaces available to us on the system. And we have ethics approval for trials with humans starting later this year. And we're working on then different functionalities in terms of making it more flexible, making it more comfortable, and different implementations of it from a communications perspective. And I guess one of the things that, because this is a research platform and we want to work with other research partners, we are funded by the European Union to make this available to the research community for free around the world. And if you go onto the InfraChip website, you can put in an inquiry there. And if you're developing a FET sensor, or if you're developing a different type of electrochemical sensor that you're looking for a reconfigurable wireless solution, the European Union will fund your access to that, and that's the InfraChip program. And what's in it for us is that it opens up opportunities to collaborate with other researchers around the world. So where are we going with this? We're integrating smart algorithms. We've got Edge IoT, AI, being brought onto the microcontrollers and onto the cloud to understand and create information from the data sets that we're getting. We're working on integrating these types of systems into clothing, textile-based electrode systems for monitoring the different parameters that we're looking at, using different flexible and sustainable materials, such as cotton or linen. We're looking at the whole area of energy and energy supply, and the opportunities for integrating thermal electric generators into the systems that we're developing, and in particular wireless power transfer as a means of charging up the batteries. And we're currently engaged with an industry partner to create an NFC-based version of our glucose sensor to give batteryless sensing capabilities for the different types of readings that we're getting. So thank you. If you have any questions, I'll try and answer them for you.